All right, this is lesson 1.2a. This is about radians. So radians are just another way to measure angles. We'll talk more about that in just a moment. So let's dive in. It says we are accustomed to finding coordinate points in a coordinate plane. So you guys are used to plotting points on a graph. It says what about an angle in a coordinate plane? Could you graph an angle? An angle is in standard position when the vertex coincides with the origin and one ray coincides with the positive x-axis. This other ray is called the terminal ray. Okay, so let's go ahead and highlight this right here. All right, this is the definition of standard position when we're talking about angles. So right here, there is a word that you should hopefully remember from last year when we studied geometry, ray. So off to the side, I'm going to draw a ray for you so you remember what it looks like. Remember, a ray is a line that goes through 2 points. All right, so it starts at a point, it goes through another point, and it ends in an arrow. So basically, it's just a line that starts at a point and continues on forever. All right, so right here it says draw a positive 45-degree angle in standard position and label the initial ray and the terminal ray. The initial ray always needs to coincide with the positive x-axis. This is my initial ray. And just as a reminder, the positive x direction is over here. It's going to the right. So if I was going to draw a positive 45-degree angle in standard position, my first thing I would do is I would start at the origin, and I would draw a ray in the positive x direction, so this way. Then it says label the initial ray and the terminal ray. So this is the initial ray. I'm going to label it I. Let's figure out where the terminal ray is. Positive 45. In this class, when we start talking about angles on a graph, you guys need to know that this way is a positive angle, so that counterclockwise. Clockwise is a negative angle. So if I go positive 45 degrees, I'm going to start on this ray, and I'm going to go counterclockwise 45 degrees. So I'm going to go to about right there. And I'm going to label this T. This is my terminal ray. And I know that this angle is 45 degrees. Okay, bullet point 2. It says draw a negative 225-degree angle in standard position. So once again, standard position. I'm going to start in the beginning, in the origin, and I'm going to draw my initial ray. It always goes this way first. Negative 225 degrees, that means I'm going clockwise. I'm going this way around the circle. So if I go here, that's 90. Here is 180. And then 225, that is 45 degrees more than 180. So I need to continue 45 degrees into this space here. So my terminal ray is going to be over here. So this one's my terminal. Now be really careful. The angle is not this. The angle went the other direction. So the angle actually goes the long way around. And this is 225 degrees. All right, finally it says label quadrants 1, 2, 3, and 4. This should be review for you all. So we're going to go ahead and do that. Quadrant 1 is in the top right. Quadrant 2 is in the top left. Quadrant 3 is in the bottom left. And quadrant 4 is in the bottom right. So there we go. That's how you graph angles. All right, let's look at this first problem in our notes. It says name all the angles that are in standard position. So right out the gate, I see 2 angles. I see this one, all right, and it might be tempting to say this one is a standard angle, but it's not, because remember, a standard angle needs to start here. So the other angle is actually this bigger one right here. says give the initial ray and the terminal ray of each angle. So first of all, when we name angles, we need 3 letters. You should remember this from geometry. You need 3 letters, and the middle letter is the vertex of the angle. So this is my vertex, okay? So when I name this red angle, it doesn't matter if you name it CDB or BDC, as long as D is in the middle. So I'm going to put the angle symbol, and then I'm going to say CDB, just like that. All right, very good. Now the initial ray, remember that's always the one in the positive x direction. This is always the initial ray. So the initial ray of this angle, that's going to be ray DC. And when we name a ray, we draw a little arrow above it. The terminal ray, that's the ray that the angle ended on. So I'm going to follow my red angle, and that's this ray here. So this ray is DB. Very good. The other angle in this picture is angle, once again, you can name this CDA or you can name it ADC. It doesn't matter. I'm going to name it CDA. The initial ray, that's the one that starts on this line. So the initial ray is still DC. And the terminal ray, that's where we end, that is ray DA. All right, so there's just a quick review on how you name and label angles and rays. Okay, now let's dive into what radians are. It says we are not going to measure things in degrees in this course. Everyone highlight that. You all are used to degrees. You know that a circle is 360 degrees. It's very good. However, oftentimes when we're talking about graphing trigonometric functions, remember this semester is all about trigonometry. When we graph these, we often use this other unit of measurement. So there is another way of measuring angles. That unit is called a radian. So that's what we're going to put in this on this blank right here. All right, we will discuss the definition of a radian later, but first we have an important formula to learn. So let's jump down here to this picture. It says use the circle and sketch an angle with the terminal ray in quadrant 2. If this throws you off, maybe do a quick label. The Q just means quadrant. So this is quadrant 2. All right, let's go ahead and do that. I'm going to sketch an angle with the terminal ray in quadrant 2. So first of all, I know that no matter what, I always need to start with my initial ray going this way. All right, now quadrant 2, that's this one over here. So it doesn't matter where you put your terminal ray, just as long as it's somewhere along this portion of the circle. So I'm going to go ahead and draw my terminal ray doing that. Okay, now it says the rays of the angle, so these two rays, they will be touching the circle. So we have one ray touching the circle here, and we have another ray touching the circle here. And it says the fancy way of saying this, so another way of saying that an angle touches a circle, is that the arc of the circle is subtended. Okay, subtended just means that an angle is blocking off part of a circle. So this is the arc that is subtended by this angle. It says label the circle's arc length between these rays as S. I have no idea why we use S for arc length, but that is the variable we use. And then it says label the radius of the circle as R. So here I have one radius right here, and I have another radius right there. All right, we then have a formula where it says the angle, so this angle is equal to, and it is going to be equal to S divided by R, where theta is the angle measure in radians, S is the arc length subtended by the rays of the angle, and R is the radius. So let's go ahead and label these parts of our formula. So this formula is very important. I'm going to put a box around it. I know S is my arc length. Now, I keep saying arc length. What does that mean? So that means if I were to take this curved arc of this circle and I were to straighten it out and then I were to measure it with a ruler, I would get a distance. That distance is the arc length. It's literally how far does this arc travel. Okay, the R, we know that is the radius of the circle. And once again, for this class, theta, which you all are used to theta, theta is an angle, but we say it is measured in radians. All right. Flipping over to the back part of the notes, right? You can see I've already highlighted something for you. This is the definition of a radian. So we can say the angle of one radian, so go ahead and highlight that, is when the angle creates an arc length on a circle that is equal to the radius of the circle. Whoa, lots of words. I'm going to clean that up for you. It means S equals R and theta equals 1. So here we go. In my picture here off to the side, I know that this arc is equal to whatever the radius of the circle is. So if the radius was 3 units, that means this arc must also be 3 units. If the radius was 10 units, this arc must also be 10 units. Okay, and I also know that this angle right here, okay, theta must be exactly 1 radian. That is the definition of a radian. It's when the arc is equal to the radius. All right, now, if you want to pause the video real quick just to think about this next question, you can. We will answer it towards the end of the lesson, but it says, can you estimate how many radians are in one circle? So if this little guy right here is 1 radian, what it's asking is how many radians would be a full rotation around the circle? We will answer this later on. All right, moving on. Let's try some problems with that formula we just learned for arc length. It says the figure gives an angle in standard position and a circle with radius 4 in the xy plane. The length of the minor arc subtended by the angle is 8.796. Find the measure of the angle. So a couple things. First of all, I know that the radius is 4. So I can go ahead and label some things here. R must be 4. That's actually also right here in my picture. Right? It says the length of the minor arc. Now, that is probably a new one for you guys. So let me give you a quick definition of minor arc. A minor arc literally just means that the arc is less than 180 degrees. In other words, half of a circle. So as you can see, this arc, we have not quite made it halfway around the circle. That's why it is a minor arc. All right, and it says that this arc is 8.796 units. That's also important. And we want to know what is the angle in radians. So let's use the formula we just learned, all right? So we know theta is equal to S divided by R. Well, I already know what S is, and I already know what R is, so I can go ahead and plug those in and solve. So S is 8.796, and the radius is 4. And plugging that into a calculator, I know that 8.796 divided by 4 is 2.199 radians. That's the measure of this angle. All right, very good. Number 3, it says if an angle measure is 1.4 pi radians and the radius of the circle is 2.7, what is the length of the arc subtended by the angle? So unfortunately, I do not have a picture in this one, but I can still go ahead and label some things. So I know my angle is 1.4 pi. So I know theta is equal to 1.4 pi radians. Okay, I can also label that the radius of the circle is equal to 2.7. So I know r is equal to 2.7. And it says, what is the length of the arc subtended by the angle? In other words, what is the arc length? What's S? All right, so let's use our formula once again. I have pi, or not pi, sorry, theta is equal to S divided by R. I can go ahead and plug in what I know. Theta is 1.4 pi, and I know that's going to equal S divided by 2.7. Now, I want to get this S all by itself. Right now, it is divided by 2.7. There is a 2.7 in the denominator. I want to get that out of the denominator. So if it's divided by, I know I need to multiply on both sides by 2.7. So I'm going to do that. All right, now, these are going to cancel. And I have S is equal to whatever 2.7 times 1.4 pi is. Now, I want to point out to you, they left pi in the measure here. So this is 1.4 pi. This is 1.4 times pi. So technically, if pi is roughly 3, this is about 4.5 or so. But because pi is left in the number, you don't have to multiply it out. So really all you have to do is just multiply those two together. So 2.7 times 1.4, that's what we're going to figure it out. That's 3.78. So this is 3.78 pi. That's how long the arc length is in this problem. All right, number 4. It says, given an angle measure of 0.625 pi radians with an arc length of 3.125 pi, what is the radius of the circle? Cool. I can label some things here once again. So angle measure, I know theta needs to equal 0.625 pi. Arc length, looks like this time I was given S. So arc length is equal to 3.125 pi. And I need to know what is the radius. All right, so once again, I'm going to start with my formula. Pi is equal to S over R. And this time I'm going to show you a different way you can go about these problems. Instead of plugging in what I know, I can maybe try and rearrange this formula first so that it says R equals, because I'm trying to solve for R. So right now I have R in the denominator of a fraction. I want to get it out of there, and I want to get it all by itself. So the first thing I'm going to do to get it out of the denominator is I'm going to multiply both sides by R. And when I do that, these r's are going to cancel, and I'm left with theta times r is equal to s. Now, when I do this, theta times r is equal to s, I've got this r, but I also have this theta being multiplied, and I want to get rid of that theta. So I kind of just gave you a hint. If they're being multiplied, I know I should probably divide that theta out. And so I am left with r is going to equal s divided by theta. Now, if you look at your original equation right here, theta equals s over r, and then you look at where we just ended, r equals s over theta, you'll notice that theta and r just switch spots. So in the future, shortcut is if you are trying to solve for a variable in the denominator of a fraction, just switch it with the other side of the equation. Okay, now I can plug in what I know. So I already know S and I already know theta. S is 3.125 pi. Theta is 0.625 pi. When I divide those two, the pi's cancel, and I am left with 3.125 divided by 0.625, and that is 5. So we can say our radius is 5 units long. All right, now let's talk about the unit circle a little bit. You all are going to do more with the unit circle in the next section of the unit. There's a whole notes page dedicated to just the unit circle, but I want you to have at least an understanding of what it is before you jump into that. So the unit circle is a special kind of graph that we graph angles on. It is specifically a circle with the radius equal to 1 unit. That's why it's called the unit circle. It's a single unit. So right here you can see r is equal to 1. It says if we have a unit circle, then the formula for the radians simplifies. It is no longer pi equals s divided by r. Sorry, I keep saying pi. Theta equals s divided by r. It is now just theta equals s. The r has gone away. So off to the side, I'm actually going to show you why that happens. So in the unit circle, and this is in the unit circle only, right? What we're about to talk about is in the unit circle only, right? If you have theta is equal to s divided by r, and you know r is now equal to 1, that means theta is equal to s divided by 1, which means theta is just s. That's where this formula comes from. All right, the radian measure of the angle is the same length of the subtended arc. So if I were to look at this arc right here, and I were to, like I said before, if I were to unbend that and make it straight and measure it with a ruler, I would also get 1. Now it says for a unit circle, 1 full revolution. So this is, what if we start here and we go all the way around a circle? All right. 1 full revolution, well, that is just the length of the circumference. If I was going to measure the arc of a full circle, then S would be equal to the circumference, C. And of course, you all remember, hopefully, that the circumference formula is 2 pi r. So let's think about this. In the unit circle only, again, only in the unit circle, if C is equal to 2 pi r, and we've already said that r is 1, well, that means C must be 2 pi times 1, which is just 2 pi. And we're talking about the circumference, the full circle, so that means the arc is the entire circle, so that means S must also be equal to 2 pi. And we just showed up here that theta is equal to S, so that means theta must also be equal to 2 pi. So right here, in other words, 1 revolution of a circle represents 2 pi radians. So you all learned a long time ago that a circle is 360 degrees. But now we know, or it is also 2 pi radians. And again, it's just another way to measure angles based on pi instead of degrees. So let's talk about these last 2 bullet points. It says half a revolution, so only going halfway around the circle. Well, if a full way is 2 pi, then a halfway must be 1 pi, because half of 2 is 1. And then finally, a quarter of a way around the circle. Well, that means I'm going to take my full circle, and quarter means to divide by 4. So I'm going to divide that by 4. Well, 2 over 4, I know that that reduces to 1 over 2. So this is pi over 2 radians. All right, next page of notes. My apologies for how long they are, but I really want to make sure you all understand how radians and graphing angles work before we dive into the unit circle and trying to graph a trig function. All right, question 5 on the second page. It says, give an estimate of how many radians this angle represents. For simplification, leave your answer in terms of pi. So that means leave pi in the answer, don't multiply it in. And it says round the coefficient to only 1 or 2 decimal places. All right, so you might be thinking, well, how am I going to do that? I just learned what a radian is. I don't really even get it yet. That's fine. You just kind of have to think through this like a puzzle. So if I know I've started here, this is always my initial ray, right? If I know before I move anywhere, I haven't moved, so I'm at 0 pi radians. If I were to go a little bit around the circle until I got a quarter of the way through, I know, because I just figured this out on the previous page, a quarter of the way around is pi over 2 radians, or this is 0.5 pi if we're going to use a decimal. If I keep going another way until I'm halfway around the circle, now I'm at pi radians. So halfway around is pi. All right, then if I keep going one more, if this is half, or pi over 2, this is a whole, or 2 pi over 2, that means this is 1.5, or this is 3 pi over 2. And my angle is in between this point here and this point here. That means my estimate must be in between 1 pi and 1.5 pi. And you can see it's definitely way closer to 1 than it is to 1.5. So whatever estimate you're thinking, maybe pause the video and write down a guess. I will give my estimate in 3, 2, 1. I'm going to say about, and I'm going to use approximately, 1.05 pi. So just slightly above 1. Now, if you had a different estimate, that's fine as long as it makes sense. You don't want it to be anywhere near 1.5 pi. In fact, if you were to split this even further, halfway between 1 and 1.5 is 1.25 or 1.25 pi. So in fact, you don't even want your estimate to be anywhere near 1.25. It's definitely still closer to that 1 mark. So again, if you had something different, that's fine as long as it makes sense and as long as it's not even close to 1.25 pi. All right, last. It says angles in standard position that share a terminal ray differ by an integer number of revolutions. It's big fancy math talk for basically you are allowed to continue around the circle even after you've completed a circle. So let's look at a problem where that happens. It says an angle with a measure of 4.3 pi would have a terminal ray in which quadrant? And it gives you a hint here, which we'll talk about in just a sec. I'm actually going to show you a different way to do it first. So 4.3 pi, I want to know, where did I end up? Did I end up in quadrant 1, 2, 3, or 4? So we can think about this visually. If we think about a circle, I know if I go all the way around one full turn, that's 2 pi. 2 pi is not anywhere near 4.3 pi. So I can probably just keep going around another turn. If I go around again, that's another 2 pi. I've gone 2 pi and then another 2 pi. So far, I've gone 4 pi. So now I'm closer. I'm at 4 pi. I need to figure out where would 4.3 pi put me. So once again, we just learned that, okay, you need to keep going. If you kept going all the way to here, this is pi over 2, or 0.5 pi. And if you look, we were at 4 before. we want to get to 4.3. We don't want to go all the way to 4.5. That would be around once, around again, and then a quarter of the way around. We don't want to go all the way there. So that means 4.3 pi is not going to be quite to this mark here. So it must have ended somewhere in this quadrant. Well, I know, based on the labels that I did right at the beginning of the notes, this is quadrant 1. So the answer to this question is quadrant 1. Now, another way to do it, the way the hint wants you to do it, says subtract or add 2 pi until you get a value in the interval from 0 to 2 pi. So we want to keep going until we get something in between 0 and 2 pi. So 4.3 is greater than 2. If we have passed 2, that means we probably want to subtract that away. So the way that the hint wants you to do it is if you take 4.3 pi, you subtract 1 full turn around the circle out of it. Well, that leaves you at 2.3 pi. You can subtract another full turn around, and that leaves you at 0.3 pi. And now you can figure out, based on 0.3 pi, you can figure out where you're at. And again, you're in quadrant 1. All right, so that's it for the notes, except I want to use this blank space at the bottom real quick before we end this lesson to talk about the relationship between radians and degrees. So once again, you guys are used to degrees. You know, you learned a long time ago that a circle is 360 degrees. Well, you also just learned that a circle is also 2 pi radians, or RAD. Both of those are true. They're just different ways of measuring it. So in other words, what we can say is that 2 pi radians must be equivalent to 360 degrees. They're saying the same thing. They're just using two different units. All right, well, if 2 pi is 360, that means pi radians must be the same as 180 degrees. And this is kind of the key to the relationship between angles and degrees. So you should be able to convert from degrees into radians, and then you should also be able to convert from radians back into degrees. This is really similar to converting between inches and feet, or feet and miles. Everything has a conversion, just like radians and degrees do. So if I want to go from degrees to radians, okay, I need to take my degree measurement and I need to get rid of the degree part of it. So I need to divide away 180. And then I need to put in the radian part of it, the pi. So I'm going to divide by 180 and I'm going to multiply by pi. So we can look at an example of this. Let's say you are given 225 degrees and you want to turn it into radians. Okay, well, you're going to use the formula right up here. You're going to take your degrees, you're going to divide by 180, and you're going to multiply by pi. All right, and now off the top of my head, I do not know what 225 divided by 180 is, but I can put that in a calculator, and I know that this is going to be 1.25 pi radians. Or if we like fractions, 1.25 is the same as 5 over 4 pi. Okay, very good. So 225 degrees, that is 5 over 4 pi radians. All right, now, if I want to go from radians back to degrees, All right. Okay, so let's say I have oh sorry, I should give you the formula first. So you're going to take your radians, all right? And it's the opposite of this one. In this one we divided out the degrees and we put in the radian. This one you want to divide the pi out because I'm trying to get rid of the radians and I'm trying to turn them into degrees. So I'm going to multiply by 180. So just like that, it's the exact opposite of the other formula. All right, so in this example, let's say I was given pi over 4 radians. And I want to know what is that in degrees. Okay, well, I'm going to take pi over 4. I'm going to divide out the pi. And then I'm going to multiply by 180. All right, now this might look a little tricky. When you have a numerator, so pi, divided by 4, divided by something again, everything you divide by, it's it doesn't matter what order you divide it in. You need to divide by 4 and you need to divide by pi. So both of these can actually just jump into the same denominator. It's the same thing. So another way to write this is pi over 4 pi because both of these can just jump into the same spot. Either way, they're getting divided out. Okay, well, if you notice, my pi's are going to cancel, and I am left with 1 over 4 times 180, and 1/4 of 180 is 45 degrees. So now I know pi over 4 radians, that's 45 degrees. All right, that is it for this lesson. Good job, everyone. Be prepared for the next lesson, which is entirely about the unit circle.